which I know you guys already know these, but let's make sure you know these. When we multiply two numbers with the same base, like 3 squared times 3 to the 5th, when we multiply two numbers with the same base, we add their exponents, right? That's the rule. You add their exponents. Notice that the bases don't change. It's 3. This is 2 3s, this is 5 3s, so I'm going to end up with 7 3s. Okay? If I'm dividing, let's say I have 3 to the 5th over 3 squared, then I will subtract the exponents, and that will be 3 cubed. Now, I am going to subtract the exponents regardless. So, if it were 3 to the 2nd over 3 to the 5th, when I subtract exponents, I get 3 to the negative 3rd. But I know that 3 to the negative 3rd is 1 over 3 cubed, which of course makes sense in terms of the original problem, because that's 3 times 3 over 3, 3, 3, 3, 3. Doesn't it make sense that I would end up with 1 over 3 cubed? Yep. And then if I have 3 to the 2nd to the 3rd, that could be simplified as 3 to the 6th. And of course, 3 to the 0th is 1, because everything to the 0th is 1, except for 0. All right, so that's just that little box up there. All right, the same exponent rules can be used when working with horizontal transformations of exponential functions. So example 1a says, determine the horizontal transformations of each of the following exponentials. Okay? So can you tell me what happened in problem A? What happened?
The x's are moved left 2.
Exactly. The x's are moved left 2. Does that make sense to everybody? So you know what your exponential looks like. You just picked that picture up and moved it left 2. How about B? What's happening to the x's there?
They're getting divided by 3.
Yes, they're being divided by 3. Remember that when you start messing with the x's, everything's opposite? What happens in C? The x's are being multiplied by 2. So if you had a table of values for the original exponential, you would take all your x's and multiply them by 2. And what happens in D? Right 1. Right 1. All right. Now, let's look down at example 2, because this is where things get a little more interesting. Each of the following exponential functions has a horizontal translation. We just talked about it. So for A, the horizontal translation would be left 3. Write an equivalent representation that has a vertical dilation and no horizontal translation. So what they mean is this. I know that I can pick up y equals 2 to the x and move it 3 units to the left. But they want me to do this in terms of a vertical transformation. So remember, if the exponents have been added, then weren't the numbers multiplied? Is that okay with everybody? What's 2 cubed? So this is, another way of writing this would be 8 times 2 to the x. So when we look at this equation this way, we think, okay, I've moved it left 3. But when I look at it this way, what do I think I've done? I've taken all of my y's and times them by 8. So that's your vertical dilation. It's the same problem, but you're thinking about it instead of a horizontal change, you're thinking about it as a vertical change.
Will the graph still look the same?
They look exactly the same. Cole, let's try it. Get out your calculator. Use a standard window and graph this equation and this equation. And they'll be right on top of each other. All you doubters, go ahead, give it a shot, see what happens.
Never judge and I never doubt.
You never judge and never doubt. Well, you're a good man. I judge and doubt all the time.
Okay, it's not like I'm doubting. It's just like it looks
No,
weird.
it's good. I know, totally, Cole. No one's being critical.
Doubting.
Try it and see.
Wait,
Yeah, they
so,
are.
like top equations, just moving the x's left 3.
Mhm.
But are we doing like the y's up 8?
In this equation, you take your original curve and take all the x's left 3 and plot the new points. Here, take your original curve, take all the y's times 8. They're not happening together. You either move all your x's left 3 or you make all your y's times 8. They're the same equation, the same set of points, but they're transforming that differently.
That's crazy.
Isn't that right? Yeah. Okay. So now we're going to do the same thing as b. b is 3 to the x minus 2. Let's see, it looks like I'm missing Annabelle and Enzo. Is that it? Okay, so we know horizontally, if you had to describe this horizontal translation, you would say I'm going to move everything right 2, right 2, all my x's right 2. But if I have to express this vertically, I'm going to make it 3 to the x times 3 to the negative 2, or 3 to the x over 3 to the second. Those the same thing? Those okay? Well, when I look at it this way, if I have a 3 squared in the bottom, isn't that 1/9 times 3 to the x? So what is my vertical dilation? I'm multiplying my y's by 1/9, or dividing my y's by 9. All right, do the last one. You are to write it like this. That's how your final answer should look, just like this one did right here. How's that look? Is that what you got? You okay? Easy? Example 2. Which of the following is an equivalent form of y equals 9 to the 2x? Which of the following is an equivalent form of y equals 9 to the 2x? Anybody have a thought on that? Scout?
Is it d to the 4 pi?
Scout thinks it's D. Anyone want to agree with Scout? Yeah, I think he's right. Remember, if the exponents, think backwards, think about what we talked about before. We said x to the 4th to the 3rd is x to the 12th, right? So if exponents have been multiplied, doesn't that mean we had a power to a power situation? So this would be 9 squared to the x. Isn't that how you multiply exponents? And what's 9 squared? 81. So there it is, 81 to the x. All right, try 4, example 4. Anybody have a thought on that? What do you think,
I
Helen?
think it's B.
Helen thinks it's B. 3 times 16 to the 2x, that one right there?
Yeah.
Now, that would be 3 times 16 squared to the x.
So that's not right.
No, I don't think that's right. A? 3 times 16 to the x over 2. So that would be 3 times 16 to the 1/2 to the x. What's 16 to the 1/2? 4. 3 times 4 to the x. Oh,
C.
I'm supposed to have a 9 out in front. Okay, so now we think it's C. Is C just like that one? Yeah, except this is a 9. Would C work? Yeah? Those can be a little bit tricky. We have to be careful. A little bit tricky. All right. Turn to the back of the next page. Check your understanding. The parent, when they talk about the parent function, they mean the initial function before you started doing all your plussing and timesing and all your transformations. So for number 1, the parent function would be 2 to the x. Just 2 to the x. That's your parent function. And then I think you can do all the rest of them. Okay? So go ahead and work on them with your partner for a second. See what kind of progress you can make. I'm going to work them out, see what kind of progress I can make. And then we'll compare notes.
Two. See, 'cause can't A be bigger than 1? That's what I don't understand the rest. I mean, C would make sense, I think, because if it's decline, like if it's got something K, then it would have to be. So that was.
All right, is there anybody who feels comfortable coming up and talking about your answers to number 1, including the graph you drew? Anybody feel good about that? You can do it? All right, go. You can just talk about it, yeah, you can, why don't you just talk about it, then you can explain anything that, like, tell them, what would you say for A?
Okay, so the parent function was
Let's listen up, you're gonna ask questions if you got them.
the x's left 1, y's move up 6.
Everybody okay with that? Perfect.
Alright, and then B. Negative 1 is negative infinity.
What do you think about that? Yeah, because think about what your exponential looks like, right? Your exponential goes forever in both directions. If you just move it sideways, that's not gonna change, it's gonna stay going forever. But what about your range?
You said the range was 6 to infinity because like this, the parent function, like even just the first term, like 2 to the x plus 1 can't get below 0. It just keeps getting closer to 0, and then we know it gets moved up 6.
So remember, the exponential function has a horizontal asymptote at 0. That asymptote is getting moved up with the rest of the picture, 6 units. So now the asymptote's at 6. Does that make sense to everyone? That your asymptote's now at 6? Because the original is at 0, period. The original exponential is gonna have an asymptote at 0, the parent function. So plus 6 moves it up 6, good.
Then the y-intercept is 0 and 8 because you just plug in 0 for x, and then 2 to the first is 2 plus 6 is 8.
Everybody remember that? Plug in 0 to find your intercept, your y-intercept, perfect.
B because C's the asymptote, right? What if C is
Graph.
negative 1/9 and A is 1/2? That make it positive.
Yeah.
But then A could also
Throw
be
that asymptote in there.
1/9. It could be negative 4. So I think it has to be D.
Okay, are you okay with that picture? So then you can answer the limit questions. What happens is we go to the left,
6 from the top.
6 from the top, beautiful, and to the right,
8.
positive infinity.
Third caption.
Yeah, just, and, thank you, Declan. Does anybody have a question about any of the stuff in number 1? Okay, did you get to 2? 2's a little harder. What were your thoughts about 2? There was only one statement that's not guaranteed. What did you think, Fred?
I said that B is the one that's not guaranteed. Actually, wait.
No, you're right.
B is the one that's not guaranteed because, we know that the A is a fraction, so we don't know that it's gonna be greater than 0.
So, and you're right. I don't know what A and C either one are. I know C is negative, but I don't know negative what. And I don't know what A is. I know it's a fraction, less than 1, but I don't know exactly what it is. I did it by process of elimination. How do I know that C has to be less than 0?
It's going,
Because the asymptote moved down. That means whatever I added at the end has to be negative, so, okay. How do I know A is between 0 and 1? It's decay, the picture's decay. And how do I know the limit is going to be C as I go to the right? So I have a picture right in front of me, right? And I'm taking the asymptote, which is at C. So I did B by default. But you could certainly explain that if you wanted to. All right, anybody come up with a new equation for number 3? This is what we were doing earlier. No one got that? No one got it? Al, come on up, put it on the board, let's see it. And did anybody find any equation, there are infinitely many answers, for an exponential function that is increasing and concave down? Anybody? You can erase some of Declan's stuff there. Good job, Declan. What do we think about Al's equation? He said 1/2 times 2 to the x. That okay? What? What negative? Here, the blue one. We're talking about Al's equation. The blue one. Yeah. We haven't gotten to the purple one yet. So the purple one, can be thought of, maybe it's be a little clearer to think of it like this. Same thing you wrote. Is this picture okay? Increasing concave down. That's upside down of a normal exponential, so the normal one would look like this, which means whatever you put here, it doesn't have to be 1/2, but it has to be less than 1. And because we flipped it over, whatever you put out here doesn't need to be -1, but it needs to be negative. Is that okay with everyone? Okay. Now I got a little practice worksheet because in not next class, but the one after that, we're going to have a little quiz over exponents to make sure that you know how to handle the exponents. So I got a little worksheet here. Oh, sorry. We're just gonna simplify each one. You don't need, I don't know what, we're not gonna write general rules, we're just going to, or I guess it is in the bottom will be a general rule. Alright, so first it's gonna be 2 squared times 2 cubed, which is 2 to the 5th. Can you do this on your own?
Yeah.
Check your answers with your partner. Alright, let's go. Fill in all those tables. When you're done with the tables, go ahead and start working the ones at the bottom, the actual columns.
Right, 3 to the 3rd is 27 times 6 to the exponents on top and the bottom.
Okay, does every group have the tables filled in? Alright, so I need somebody from Avery, one of you guys in your group, would you read us your answers nice and loudly to the first table?
2 to the 5th, 3 to the 6th, 4 to the 8th, x to the 6th, and x to the a times b, or a plus b.
A plus B, there we go, A plus B on that last one. Any question about table 1? All right. Table 2, the one right under that. The one right under the one Avery did. Trowbridge, one of you guys back there, can you do that? The table underneath Avery's?
3 to the 3rd, 2 to the 3rd, 5 to the 4th, 4 to the 2nd, x to the 2nd, and x, and then a minus b.
X to the A minus B?
Yeah.
Anybody have a question about that? And so we're working on this paper right now. Okay, and then the last table. Mark and Noah back there, would one of you guys read your answers to the last table?
2 to the 6th, 4 to the 15th, x to the 12th, 6 to the 3rd, 12 to the 3rd, x to the 3rd, y to the 3rd, x to the a, x to the b, y to the b.
Perfect. Anybody have a question about any of those? Okay, let's get busy. Let me know when you have all 9 of these done. This is more like what the quiz questions will look like. So let's get these 9 done. And we'll have the answers put up on the board.
I'm working so far ahead.
No, that's 6. Oh no, it isn't. It isn't. I just read it. When you're multiplying, use that.
If there's like variables on the top and not variables on the bottom, do you want us to like separate it into 2 or just like should it be 4/3 times x squared y, or should it be 4x squared y over 2? We have to show her like what's the short process?
No, I want you to show your answer, and then if there's questions, then I come back later and ask you to explain it. Alright, so we're putting our answers up here, just our answers. But then if you have to question it, you'll be ready to explain how you got your answer.
I was about to run for 1 minute.
Scott, don't use that. It's my favorite color, that's why I don't throw it away, but I go in.
Yellow's your favorite color?
It is.
The last
And
time
I
this
see my yellow second. Okay, I still need 4 and 5, guys.
Yeah, you see try.
I'll do it with everyone David does. I'll do 5.
All right, we gotta check them and talk about them if we missed anything. You guys in the back might not be able to see number 3. It's 2x to the 12th, I think, y to the,
17.
this looks like a 16 to me. It's x to the 17th, y to the 16th. That's what that one says, okay?
Negative 17. When
All
on
right,
back.
are there any of these we need to discuss?
Can we go over 3?
Yep, just, I'm checking just a second. That one is 4u to the 6, v to the 8. And you guys put stuff on the board, remember there's people in the back, so make sure it's good.
I remember you do that. Number 8.
Okay, so we need to talk about 3,
Wait, so.
somebody said.
Yes.
So 3 is 2x, x to the 4th, y to the 4th, to the 4th. All right, so first thing we're gonna do, we're gonna follow PEMDAS rules, so we're gonna take care of this exponent first. So 2x, and then I'm gonna have x to the 16th, y to the 16th, does that make sense? This is all this is being multiplied together. So what do I do with these 2 exponents right here? Add them, so that's 2x to the 17th, y to the 16th.
Oh, I thought that said 12.
I know, it's 17. Okay, anything else? I match all those, Declan?
On a quiz, if we have like, if all of the variables cancel out and like for number 6, since it's like 2 to the 6, you want us to leave it at 2 to the 6 or go all the way up to 16?
Well, the general rule of thumb is if it's a small one, like 2 to the 6, you write it out.
Alright.
If it were 2 to the 28, you would leave it 2 to the 28. Okay, all right, let's flip it over. Here's the good stuff back here. This is where sometimes we start getting confused when we have negative exponents and fractional exponents. So let's review those rules. 0 to the 0th is undefined. Did we talk about that back in chapter P? I can't remember because we did a bunch of this in chapter P. Now, why is 0 to the 0th undefined? Anybody know? Anything to the 0 power is 1, except 0. 0 to the 0th is undefined. Type it in on your calculator. 0 to the 0th.
Limit on us.
It hopefully says error.
Why would I?
Error.
Blame it on the domain.
Okay. So let's talk about this for a second. If we have x to the 4th over x to the 4th, everybody in the world knows that's 1. Because when these are the same, they're going to cancel out and make 1. But if you subtracted the exponents, you would get x to the 0th, right? So that's why anything to the 0th power is 1. But the argument, anything to the 0 power is 1, is based on this subtraction of exponents. So it's based on a division. Well, can you have 0 to the 4th over 0 to the 4th? That is how you would get 0 to the 0th, right? Can you have that? No. Therefore, 0 to the 0th is undefined because it's generated by an undefined fraction. Okay, all right. Negative exponents. What's 7 to the negative 2nd? 1 over 7 squared, so 1 over 49. How about 2 to the negative 1st? 1/2, beautiful. How about 1/3 to the negative 1st? 3, absolutely right. X to the negative 3rd? 1 over x cubed. And how about 2 plus 4x to the negative 2nd? 1 over 2 plus 4x squared.
1 over 4
4
plus 8x squared.
Oh, now be careful, be careful,
Oh,
be careful,
Ooh,
be careful. Whoa, whoa, whoa. This would be a FOIL, FOIL. So if you want to simplify that, you absolutely can, but don't be giving me 4s and 16s. There's more than that, right? So it would be, if you're gonna FOIL it out, it would be 4 plus 16x plus 16x squared. Did I do that right?
Yeah.
So quantities to powers, you don't distribute the power. Quantities to powers are gonna be a FOIL. Well, a distribution, no matter what. You hear that, people? Okay. All right, now radicals, fractional exponents. Every time you see a fractional exponent, like 8 to the 2/3, the first thing you think of is, I got a radical. A fractional exponent is a radical. Under the radical is gonna go the base. The denominator of the fraction is the root, and the numerator is the power. So this means the cube root of 8 squared. So the cube root of 8 is 2, and 2 squared is 4. What does 16 to the 1/4 mean? 4 through to 16? 2. What does 4 to the 3/2 mean? Square root of 4 cubed? 8. And when you have a negative and a fraction, you want to take care of the negative first. So this is 100 over 1 to the negative 3/2. So think of that as 1 over 100 to the 3/2. So take care of the negative first, and then deal with the radical. So what's the square root of 1/100? 1/10. And 1/10 cubed is 1 over 1,000? Everybody okay with that? Okay, all right. This is all gonna be no calculator exercise. So make sure you know about a calculator. All right, try part 3. Let's see if we can get these 6 up on the board before the period is over. You guys already have that over there, Fred?
We've got all but 6.
Oh, 6 is what?
Look on 6.
Okay, then.
Yeah, Fred.
I will write it up on my note.
See it right now.
Like 20 minutes ago.
6 is light.
No, 6 was light with no reaction.
Light with no reaction. You got 6?
Yeah. That's all. You make a part Lewis in Spanish. Are you 4? So, no evidence.
Is it untraceable?
He's Dexter.
This is Ford. What does that Cathedral Math League t-shirt mean? The we are .9 to be.
We're number 1 in
0.9 bar is things. Very cool.
If I get that wrong, I'm gonna be so sad.
What, 6?
Yeah.
Should I put 2 up there? Just put 1?
Yeah, that's it.
Let me look like you're smart.
Well, somebody got 6.
That was a cool
At least has an answer. I don't know if it's right or not.
I know. I'm like, open up the class, I'm 6. You know, nobody else would got it. It's a real tough one.
That's rough. March birthday. You give off March energy. You give off November. No shot. There's no way. December. I knew it.
Number 2 is light.
Always November. Landon, you're
Bro, why did
Landon,
you?
Landon, you're September.
Oh, no way, bro. Stop. It's too much
Wait.
work.
No.
You read too many lines, bro. You
One,
need one line.
June.
All you
Is that why it's called one?
Yes.
What?
One through
Trying to
one.
figure out everyone's birthday month.
Cut you. Keep
I'm
drawing
usually
one
so
thing.
good at it. Like I can look at them and be like,
One was there.
you have
There you
such
go,
a
just
March
the
birthday,
101.
bro.
Kinda
You just look like you look like a March birthday.
Are you
Okay, we
gonna?
still need
Hey,
4 and 5.
Lizzie's a March birthday too.
One, bitch, one.
101.
For Lizzie, knew it's a bad thing.
You like gonna?
Who corrected number 2? David, who corrected yours?
No.
It's
He would've-
fine, stop it. Quit acting goofy.
Lock in.
This is Ford. Did you hear him making fart noises earlier? Ford's been messing around.
What? Why are you making accusations?
Accusations.
Accusations
Come on, let's get 4 and 5 up there. We have some talking to do, I think.
Alright.
Should I just do it? Ball hog, ball hog.
Is that a punch drop?
Yeah, I totally did.
Yo, 5 is 1 over something.
Wait, you got that?
What did I mess up number 1?
I think it was at the top half. Okay, I don't know. Cool, but don't when you subtract it, whole from part of that, it includes the exponents out. Like the fractional exponents out of the top, since they're, what?
You have to get fractions out of 5.
I think Big Al should do
Fractional
it.
exponents.
Alright, bro.
Big Al, you got it.
That's the,
How we looking, Big Al?
that's a root thing.
Are you saying we have to make them roots?
Big Al,
No, we're gonna talk about that. Al's got a point. We're gonna talk about it in a second. All right,
I messed
so,
up.
does anybody besides me have some concerns about some stuff that's up there? Olivia, what are you concerned about?
Oh, I just
Oh, okay, well, that's not what I'm
Number 2
talking
looks
about.
off.
Let me see
Anybody
one.
get an answer different than what we got? Al?
Well, like for like you can't really have like a fractional exponent on the bottom because you can't have a like a root on the bottom,
Okay.
and that's
Okay, so in terms of simplifying exponents, you have been taught that fractional exponents on the bottom are not acceptable because fractional exponents are radicals and radicals aren't acceptable, okay? That is now, we're past that now, okay? So unless you are specifically told that you are not allowed, or that you have to rationalize the denominator, that's no longer required. So we're going to have things, especially in trigonometry, where we're gonna get things like 2 over root 3. And that's easy enough to rationalize, but points aren't deducted if you don't, okay? Unless you are specifically told to rationalize your denominator. So right now, Al, I'm not gonna worry about that. I was specifically told though that I can't have negative exponents, so I better not have any negatives up there. Okay,
No name.
does any answer bother you? 1 is wrong,
Yeah, shouldn't it be like?
1 is wrong. Now, here's the deal, folks, here's the deal.
Oh wait, I know.
When you have,
Oh wait, you did 3, bro. I thought you did number 2.
when you have a to the 1/2, b to the 1/2, and you are raising that to the negative first power, what do you do with your exponents? Don't you multiply them? So this would be a to the negative 1/2, b to the negative 1/2, which is 1 over a to the 1/2, b to the 1/2. Now, that is not rationalized to L's point, but for this exercise, it's not. Now, I really don't know what happened. Actually, I kind of see what happened there. if you would rather, could we have written it and said, okay, something to the negative first means 1 over it? Don't end up at the same place? However you thought about it? Alright, so number 1 is off. I'm okay with number 3, well, and 2 and 3, I'm okay with. I am okay with number 4. Again, not rationalized, but that's okay for this exercise. I am okay with that one, and not okay with this one.
Ooh, no.
You said it was light work.
So
Oh, it
let's
is light
get-
work. I
let's
just
go through
so many
this
steps.
one,
You got, hey, you know what
and then you can
We
answer
were
the
farting
questions
in
for the run out
Spanish
of
last
time
week.
here.
We were just making.
So I'm gonna distribute, oh, wait a second.
Oh, is he right?
Could been, what did you say the answer was?
X to the 15 over 4, and then y to the 17 over 2.
Alright, I am gonna have to check, cause I see I made a mistake here. And I'm gonna have to fix that. So I don't know if that's right or not. but
Plus
I
aura,
know
plus
that
aura.
I
We
have-
might never find out.
Guess we'll never know.
We'll know tomorrow.
Yeah, what happened to my aura, bro?
Your,
We don't really know yet.
what is this? 2.4 homework. 2.4 homework is due on Monday. Alright? So tomorrow we'll answer any more questions you have about this. And move on. Okay?
I want to find out if I'm right or not.
Yep, we're gonna find out tomorrow.
You'll never know.
Nope.
We're gonna know tomorrow. Smart pants.
He'll know.